In right triangle ABC, angle C is a right angle and BC equals to 162. Point D on side AB is connected by a line segment with point E on side AC, so that line segment DE is parallel to side BC and CE equals to 2 times AE. What is the length of line segment DE? Okay, first let me draw a right triangle. Since angle C is a right angle, we can take C over here, A over here, and B over here. And we have the information, the length of the line segment BC is 162. And now take point D on side AB over here. And take point E on side AC, that is over here. Now let me connect the 2 points D and E by a line segment. And the question says this line segment DE is parallel to BC. Since these two line segments, ED and CB, are parallel, we can consider this AC and AD as transversal. Then this angle and angle over here are corresponding angles and they must be equal. Since this is right angle and here also we must have right angle, and the angle measure over here and angle measure over here must be equal because they are corresponding angles. Okay, here the two angles of the bigger triangle ABC are congruent to the two angles of the smaller right triangle ADE. By angle similarity postulate, the two triangles are similar. Okay, now let me take the vertices of the bigger triangle, bigger right triangle, that is a triangle ABC. Okay, now let me write the corresponding vertices in the smaller right triangle ADE. And A is the common vertex for both the triangles. Since I have taken A at first, let's take A over here. And here in the bigger right triangle, I have taken B. So for B, the corresponding vertex is D, the smaller right triangle. And the third vertex is E, the smaller one. Now let me write the ratios of the corresponding sides. Take the side AB in the first triangle. The corresponding side in the second triangle is AD. That is, we have to consider the letters of the same position. Let me write over here. Take the side BC in the first triangle. The corresponding side in the second triangle is DE. Take the side AC in the first triangle. The corresponding side in the second triangle is AE. Okay, since these two triangles are similar, the corresponding sides are proportional. That is, the ratios of the corresponding sides must be equal. Okay, let me equate them. And in the question, we don't have any information about the lengths of AB and AD. So we can reject this ratio. Let's consider the equation we have over here. For BC, we have the length, that is 162. Let me plug in. And we have to get the length of the line segment DA over here. So we can write this DA as it is. And we don't have the length of AC and length of AE. But we have an information about the length of AE. It's over here. That is CE equals to 2 times AE. Okay, let me assume X as the length of AE. Then what is the length of CE? 2 times X. That is, the length of CE is 2X. What is the length of AC? So to get the length of AC, we have to add this X and 2X. Then I'm getting 3X. Okay, here I got the length of AC, that is 3X. Let me plug in this 3X for AC over here. And the length of AE is X. Let me plug in X for AE. This X will cancel out. I am getting 162 over DE equals to 3. Okay, now let me multiply both sides of the equation by DE. Let me do it. Then D over here will cancel out. I am getting 162 equals to 3 times DE. Okay, now let me divide both sides of the equation by 3. This 3 will cancel out. When I divide 162 by 3, I am getting 54. On the right side, we have DE. Here I got the length of the line segment DE, that is 54 units.